Which of the following compounds contains a polar covalent bond? And then we have our four answer choices. Is it going to be water, H2O? Is it going to be methane, CH4? Oxygen, gas, O2? Or my favorite? Tell me why. Tell me why NaCl is so special to me. If you've watched the general video, you will know why. So let me know in the comments, all right? But anyway, between these four, we have to know which one is polar covalent. So, first off, it's a covalent bond, which means that we're dealing with a nonmetal and another nonmetal. So the idea here is that generally speaking, because, there's always exceptions in chemistry, but generally a covalent bond is between just nonmetals. So it's really important to know who your metals are, who your nonmetals are, and kind of pick that out, right? Hydrogen is a nonmetal. So we got nonmetal, here's another hydrogen. We got two oxygens, and oxygen is all the way on the right side of the periodic table. That's also a nonmetal. We have carbon, which is very, very close to oxygen. That's a nonmetal. And then we have sodium chloride. Na is a metal. And chlorine is a nonmetal. So, boo-hoo. We already found out one that's not going to be it. This is totally not correct. This would be a ionic bond. Ionic bonds are generally between metals and nonmetals. So now we're down to 3. Now we just got to find out of all of these covalent ones, which one is polar. Well, there's a couple of ways to go about this. We can do it the electronegativity way, or we could do it the acronym SNAP. S-N-A-P. Now, if you have elements that are symmetrical, aka, I just put sim here, but if you have elements that are symmetrical or they are exactly the same, your bond is going to be nonpolar. But if your bond has asymmetrical, aka if you have different elements, then you would be classified as polar. And I should have did the second one in a different color, but maybe what I'll do is we'll drop this down just so that you know that the symmetrical is nonpolar, asymmetrical is polar. So let's see if we could knock some of them down here as well. Now between the H2O, right, the bond is going to be between the oxygen and the hydrogen, right? And it doesn't matter whether you know that it's a double bond, a single bond. Doesn't matter if you know any lone pairs, the correct Lewis structure. I don't care. You just have to pinpoint the bond, right? The chemical bond. And as of this, right now, I have an O and an H. They are definitely not the same. They are different, right? They're asymmetrical. So by this right now, we could say that H2O is the polar covalent bond. But now if we do the same type of idea for CH4, I know that I'm going to have a carbon that's bound to a hydrogen. Once again, doesn't matter whether it's single, double, triple, whatever. We just have to have the carbon with the hydrogen. But these are also two different elements. One's carbon, one's hydrogen. So according to your SNAP, I am also in the different category, which by SNAP laws, it's classified as polar. O2, I have an oxygen bound to another oxygen. Once again, it does not matter whether we know that it's a double, single, triple, I don't care. But the idea is that I have two oxygens. These are totally the same. So therefore, this would be non-polar. Keep in mind, we are looking for the polar one. So now we have two out of the way. We just have to do a little bit more work to find out which one is the true polar bond. According to SNAP, we couldn't really determine it. So that means that we go to the next level and we go to electronegativity values. Now, let's go to a periodic table and get the electronegativity values. Electronegativity is going to tell us who is pulling those electrons in the bond more to itself, whether it's pulling it more to oxygen or carbon or hydrogen. But let's head on over to the periodic table and take those values. Here we are. We have a beautiful electronegativity value periodic table for you guys. And just know that we had a couple of elements here, right? They were all nonmetals. So carbon, which is 2.5. Your electronegativity values are on the bottom, not your atomic numbers. Those are the ones on the top. So we have 2.5 for carbon, 3.5 for oxygen, and 2.2 for hydrogen. So 2.2, 2.5, and 3.5. Let's go back to the question and see how we're going to use them. Okay, so here we are. I'm just going to take these and put them over here, right? And we'll get rid of these because we're still deciding. We said that hydrogen's electronegativity is 2.2. Carbon's was 2.5 and oxygen was 3.5. That's correct because fluorine is 4. Now, when you're talking about electronegativity, we have to take the electronegativity difference, which means that we just have to subtract the values from the bond. Now, just know that the electronegativity difference, it's always going to be a positive number. So just take the bigger number and subtract it by the littler one. 3.5 minus 2.2, what is that? Oh boy. Let's see, if I go up here, my brain, hold on, I just did as many videos. So that's an 8. Then we got to get to a 5, so that's 1.3. There we go. And then 2.5 minus 2.2 is 0.3. I mean, difference in values. One is low and one is relatively higher than the other. Now, just know that if we're talking about a polar covalent bond, that has the pull. That's the asymmetrical one. And by electronegativity differences, polar molecules have an electronegativity difference of 0.4 to 1.8. So the higher one would be the polar bond. Nonpolar is basically lower than 0.4. So this would actually be nonpolar. But this is actually a great example to show you that sometimes snapping it out doesn't always work. But I would definitely remember that a CH bond is always classified as nonpolar. If you commit that to memory, usually they always like to use this one to trick you up. And plus, carbon and hydrogen bonds are the most widely used in organic, biochem, physiology, so it's good to know that bond. But in this case, since we wanted to find out the polar covalent one, that is H2O. And we are donezo. Let's get it. So hopefully this helped. Let me know in the comments. Thanks so much for viewing the video. I love hanging out with you guys. I hope you're doing well out there. Good luck on those tests and quizzes. And if you want more practice problems just like this, head on over to our website, glazersguide.com. The link is in the description and at the end of this video. If you want to click and head on over, guess who will be there? Me. Me and my brother. So we got you covered. We got tons of videos. We got deep dive videos. So it's just one big party. So let's go. For more practice and for more fun, head on over to glazersguide.com. Yeah? Okay. I'll see you there. I'll see you there in 2 seconds. Okay. Bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.